Unlike factories, farms in the outdoor world, they are much more in structured environments where they have a lot more variability, and so this poses unique challenges. So getting a robot to actually pick fruit is really hard. I'm Joe Davidson. I'm an associate professor at Oregon State University, and I'm an expert in robotic manipulation and field robotics. My group works on robotic fruit harvesting, and this is the prototype gripper that my student Alejandro has been working on for the last several years. And the way that this would work is we would attach this gripper to a robotic arm, and there's a camera in between these suction cups that would help us identify where the fruit is in the tree. And the arm would reach out towards the apple. We would stick it with these 3 suction cups. And it's hard to see here, but after we make good contact or with the suction cups, we would have 3 fingers that would extend out and grab the apple, and then the arm would pick the fruit from the tree. Our robot can pick apples, but not nearly as well as a person. And our intent was never to actually create a commercial machine that could be adopted by our farmer. Rather, that we were doing the basic research and trying to answer these fundamental questions like how can we use lots of sensing and data to train robots to pick fruit similar to humans, and hopefully generate new knowledge and outcomes and methods that companies could go and adopt when they try and create their new machines for the market. So there are increasing concerns about the future availability of farm workers, and there are shortages today. And so I don't see robots replacing people. I see them helping fill the gaps that are there today. Training a robot or creating a robot to pick fruit is actually a really hard problem. And environments like warehouses, we can design and control the environment around a robot. But when we're out in the fields and farms and nature, we have to fit robots into systems that already exist. And they're a lot more unstructured usually, and they have a lot more variability. And so for a long time, one of the hardest problems with fruit picking robots was getting robots to effectively see the fruit. But with advancements in deep learning and computer vision, they're much better at this today. One of the last hurdles for robots to actually effectively pick fruit is the problem of dexterous manipulation. And so if you were to go and watch a professional fruit picker, they're out in the orchard, they're using both hands. Sometimes they're using one hand to push branches or leaves out of the way, and they're using their other hand to reach deep into the canopy and actively apply these special picking patterns to pick fruit. And they do this all day long, and they're really fast, and they're much better at it than robots today. So I really like working on ag robots because I see that as my opportunity to make a positive impact in our future food systems. I also really enjoy working with farmers and growers to collaborate with them to identify their needs and what they need in technology to actually create systems that are adoptable. And finally, I really like working with folks from ag extension and horticulturalists and crop scientists outdoors across Oregon. So farm robots aren't actually a new idea. People have been working on them since the 1980s, for example. A group from Europe worked on an apple picking robot in 1986. And today, farmers can buy things like autonomous tractors or UAVs. There are robots that help with things such as using lasers to weed fields. But one of the last great hurdles for robots on farms is doing those things that people still do that require a lot of hand actions in the environment.